So what we're going to do today, we're going to talk about how to find the discrete value of um, a normal distribution. So let's say, for example, we have a problem like this. If NP is greater than or equal to 5 and NQ is greater than or equal to 5, estimate P where your discrete value is fewer than 7, with N is equal to 14, P is equal to 0.5, by using the normal distribution as an approximation to the binomial distribution if NP is less than 5 or if NQ is less than 5. Then also state that the normal approximation is not suitable. Okay, so what we have to do here, we have to go through a standard process. Now, on this particular problem, what I'd like to do, I'd like to introduce some tools and some procedures in Microsoft Excel. Now, we all have access to Excel through your college's website. They do offer a free download for Excel, free charge for all students. So the process to figure out how to solve this problem right here, well, first things first, we have to find the mean, okay? We have to find the standard deviation, and then we use this code right here, norm, N-O-R-M, dot D-I-S-T. Okay, that's the function we're going to use in Microsoft Excel, and we're going to go over that in just a little bit. And then this is actually the process to type in your information in Excel. Okay, so how we're going to do this. Okay, so step 1, find the mean. Okay, so for our particular problem, scroll here. Okay, so for our particular problem, our N is 14 and our P is 0.5. So in order to find the mean, we have to do N times P. Okay, so in this case, it would be 14 times 0.5, which gives us a mean of 7. All right, now step 2, find the standard deviation. Find the SV, standard deviation, just for abbreviation, okay? So what we have to do here, we have to do the square root of our mean, which in this case is 14, times our probability for success, which in this case is 0.5, and then times our probability for failure. Now, our probability for failure is 1 minus P, which in this case, 1 minus 0.5 is still 0.5. So when we go ahead and calculate that, 14 times 0.5 times 0.5 again, we get now the square root of 3.5, which gives us approximately 1.87, give or take a few. So let's do 1.8708 for a standard deviation. Okay. Now for step 3, this is when we go to Excel. Okay. We want to use the function NORM, normal, period, distribution, D-I-S-T. Okay? Now, in order for us to do this, we have to enter the following information just as we had earlier. So it's normal, N-O-R-M, dot D-I-S-T. Now, the x value that we had written originally, okay, this little guy, that's a random variable within our range. So in this particular problem, we have our range, which is fewer than 7. Okay, so I'm going to pick a number that is less than 7. Let's try, I don't know, 6.5, just for kicks and giggles. Okay, so we're just going to pick a random variable that is fewer than 7. So therefore, I picked 6.5. Okay, we'll try and get it in there. And then, comma, your mean, which is 7, comma, your standard deviation, 1.8708, comma. Now, in the cumulative part that we had written down earlier, in this particular section, instead of the word cumulative, you would write true. You would type in true, and then close your parentheses. Okay? So now let's take a look at it on Excel. So, in order to do a function on Excel, you do equals, and then norm.dist, open a parentheses, and see right here it gives you the recipe card on how to type your information in. So we're going to type in our x value, our random variable, which was 6.5, our mean, which is 7, standard deviation, 1.8708, and then our cumulative, which in this case, true. And then we close the parentheses and hit enter. So therefore, our discrete random variable, or the probability of something occurring that is less than 7 in this case, is 0.3946, or 39.46%. So when we go back to the problem, we want to round to 4 decimal places. So 0. What do we have? 3946. 0.3946. And let's check it out real quick. 3946. And there we go. Okay. So in this case, we're using Excel to do all the calculation for us. You definitely want to work smarter and not harder on these kinds of problems. Now, I will say you can do this calculation by hand by using the normal distribution formula, but I promise you, you will get bogged down in the calculation. So as always, let me know if you guys have any more questions of any kind. I'm always happy to help, but definitely use your calculator and use Excel to do a lot of the calculation for you. You definitely, like I said, you definitely want to work a lot smarter on these problems, because in statistics you will get bogged down in the calculation, and it's very easy to make a mistake on these guys. Okay, so as always, let me know if y'all have any questions. I'm happy to help, and until next time, happy to help, guys.